fraction, the denominator can't be 0. And we were looking at the asymptotes. We know that you would have vertical asymptotes, and when you wrote those, you always had to give the equation, so x equals a number. And then we had our horizontal asymptotes, which were y equals a number. So today we're talking more about where these asymptotes come from. So that is our first thing. If you have a vertical asymptotes, it is always going to be x equals some number. And where does that number come from? I think a few of you made the connection. Your vertical asymptote was always the thing that got taken out of the domain, right? So that number is what makes the denominator equal 0. So if something makes the bottom equal 0, that is a vertical asymptote. Horizontal asymptotes. These are a little less clear-cut. They are always going to be y equals something. But the rule is actually going to be based off the degrees. So the first case, it'll be y equals 0 if the degree of the top, or the numerator, is smaller than the degree of the denominator. So if it's like an x on top and an x squared on the bottom, or x squared on top and x to the 5th on the bottom, if the degree on top is smaller, it's just a y equals 0. You will get y equals some number if you have the same degree on top and bottom. So if we have an x squared and an x squared. To find the number, you will divide the leading coefficients. So horizontal asymptote happens in one of two cases. If it's the degree on the top is smaller than the degree on the bottom, or if it's the same degree on top and bottom. An oblique asymptote is going to be of the form y equals mx plus b. And this happens if the top degree is 1 higher than the bottom degree. We have like an x cubed over x squared, and the degree on the top is 1 bigger. That's an oblique asymptote, and we will have to find a full line. To get that line, we have to do long division. Hey.
What are we doing for, is it just mod itself?
Yeah, I'll post a video. All right. So these rules are something that we're really just going to have to memorize. I can give you some options for, I can show you why they are what they are, but I don't think it's going to make it any easier. It's best to just kind of learn what the rules are. However, we are going to be doing it a lot. So today, what we are doing the rest of the day is just practicing finding asymptotes. We're not even going to draw the graphs. We are just going to look at equations and figure out what the asymptotes are using these rules. First, I want to review, we did domains on the section Friday. So I'd like to recap how we did that. So we might just do a couple examples, if that's okay with everybody, of finding our domain. What did we have to look at?
Denominator.
Mm-hmm. And we know that the denominator cannot equal 0. So to solve this, we could add over our 4, square root, plus and minus, so x cannot be
Plus or minus 2.
good. My general rule, I told you, if it's more than one value, you can list it. If it's only one, I do want the interval notation. In interval notation, this would be everything smaller than -2, everything between -2 and 2, and everything bigger than 2. B, what would we do?
X cannot equal.
Mm-hmm. So since it's just one number, x can't be, I would expect the interval, so that would be one more. What would we have to do here? Mm-hmm. We could do this shortcut. What multiplies to -21 and adds to positive?
-3.
So what can an x not be?
3, -7.
Good. If you wrote the interval, which I've told you, if it's more than one, I won't make you do, but you certainly could. It'd be everything smaller than -7, between -7 and 3, and bigger than 3. All right, so we're good with domain? So the domain is really kind of like the vertical asymptote. So this one would have a vertical asymptote at +2 and -2. This one would have a vertical asymptote at 1. So the domain and the vertical asymptote piece is essentially the same. So the next few examples, I'm just going to ask you to give all the asymptotes. So everything will have vertical, and then could it have both a horizontal and an oblique? No. Horizontal happens if the degree on top is smaller or the same. Oblique happens when the top is one bigger. So you can have vertical and horizontal, you can have vertical and oblique, but you will never have horizontal and oblique in the same problem. So let's find our asymptotes. So how would I get my vertical?
Denominator to set it equal to 0.
Mm-hmm. With the domain, we're always saying x can't be those, but for the vertical asymptote, it's saying when does x equal those things. So you would have to add over your 1, divide by 4. How do you get rid of an x squared?
Square root.
and with that, plus and minus. So my vertical asymptotes, we actually have two of them, positive and negative 1/2. Asymptotes are lines, so I will expect full equations. So if you don't have the x equals, it will be wrong. You could type these separately, or write these separately, x equals 1/2 and x equals negative 1/2. It'll have two of those vertical dashed lines that we don't hit. Now we have to look at the horizontal or oblique. We've already said, can it have both?
No.
No, it'll be one or the other. It's based off the degree. What's the degree of the top?
2.
And the bottom?
2.
If it's the same degree, which type is it?
Horizontal.
Horizontal. And what did we do?
Divide the leading coefficient.
So horizontal is always y equals, what's 8 divided by 4?
2.
And if we have a horizontal, there is no oblique.
When did you say there was an oblique?
If the degree on top is 1 bigger. So if this had been 8x cubed, then it would be oblique.
Then what do we do to find it?
We will have to do long division.
Long division?
All right, why don't you guys try B on your own? So vertical is x equals whatever makes the bottom 0, which is, okay. We have to decide if it's horizontal or oblique. What's the degree of the top?
1.
And the bottom?
1.
So that means there is no oblique, it's horizontal. You divide the leading coefficients. This is like a 3/1, which is just 3. Why is this 3?
Do we have to put none on oblique every time?
Only, when it comes to the test for this, I'm going to say if it doesn't have one kind, tell me none. But in general, no. Only if I specifically said in the directions.
Okay.
All right. Next one. So what do we have to do to find the vertical asymptote? Okay. If you set x squared plus 1 equal to 0,
It would just be, or plus or minus.
I. Can we graph I?
No.
So what should I say for my vertical asymptote?
None.
None. You may get some that don't have vertical asymptotes because they turn out to be imaginary, and that's okay. All right, now we need to decide if it's a horizontal or an oblique. What's the degree of the top?
1.
What's the degree of the bottom?
2.
So, what's the rule?
Oblique has to be, the top one has to be higher.
Right, for it to be oblique, top has to be higher. So this is like a horizontal, and I told you if the degree on top is smaller, it's an automatic 0. Another way to think about this, I didn't have an x squared on here, did I? So that means it's like 0x squared. So if you divide the leading coefficients, 0 divided by 1 is 0. And then we know that if there's horizontal, there is no oblique. All right. D. What can I do?
Set the denominator.
You can take,
So if I set that equals 0, what can we take?
x out.
Mm-hmm. Okay. Let's go ahead and factor that. So that factors into x minus 2, x plus 1. What could you do on the top? Do you guys notice anything?
X squared.
We are going to be looking at problems like this more tomorrow, but I thought I might go ahead and touch on one. What could you do with these x's?
Cancel.
You could reduce an x. When we get ready to actually start graphing these things, we will always write them in lowest terms first. So when we come to the test, I will have it broken down into like A, B, C, D, and I will say step A, factor the numerator and denominator, and reduce. Step B, then give me the asymptotes. So we are going to reduce before we do the asymptotes. Okay? It's a little bit different than when we talked about the domain. I told you you couldn't reduce first. What happens when something cancels out? It creates what's called a hole in the graph, which is like an open circle. So we'll look more at those tomorrow. But if it's going to cancel, it doesn't put an asymptote on our graph. So that's why we need to go ahead and reduce here. So my vertical asymptotes, what makes the bottom 0?
2, -1.
X equals 2, x equals -4. Now, as far as finding the horizontal and the oblique, we can look at our factored one. We can look at the original too. If I looked at my original, what's the degree of the top? What's the bottom? So if the top is bigger, that means it cannot be a horizontal. If it's bigger by just 1, that means we have oblique, which is the case here. To find an oblique, we're going to have to do long division, which we did way back in the day. It's been a bit.
It's way harder than synthetic.
It is harder than synthetic. However, here's the good news. We don't have to do the full long division. We just need to get a line, y equals mx plus b. So we're actually just going to do a couple steps of it, and then we're going to stop. Okay? The top goes underneath. So this was x cubed minus x squared minus 2x. The denominator goes on the outside. Oh, hold on. I flipped those, didn't I? I said the top, and then I wrote the bottom. The top was, what, 3x to the 4th minus x squared. Let's put in a 0 for my x cubed. And so the outside is my x cubed minus x squared minus 2x. Okay. I know when I say long division, everybody gets nervous, but it's not going to be that bad because we're not going to do very much of it. You start by dividing the first numbers. What is 3x to the 4th divided by x cubed?
3x.
Okay. Then we multiply. 3x times x cubed is 3x to the 4th. 3x times x squared is negative 3x cubed. 3x times negative 2x is negative 6x. What's wrong?
I'm confused.
Okay. I'm just taking my 3x and I'm multiplying it by this. So I just distributed, and that's where I got these numbers. We are actually very close now. What did we always have to do to this? Subtract it off. So we usually just distributed a negative through here. So those cancel. What is 0x cubed plus 3x cubed?
3x.
Negative 1x squared plus 6x. Those aren't even like terms, but you know what? It doesn't matter because we're not even going to need that. Here's all we have left to do. What is 3x cubed divided by x cubed?
3.
3. We have our mx plus b. So our oblique is y equals 3x plus 3. Okay, I know that was a little more tricky. I don't expect you to be able to do those on your own yet. Right now, I'm wanting you to recognize when there will be an oblique, which is when the degree of the top is 1 higher. Okay, we will be doing a lot more of these before we get to homework. I repeated, so I did 3x cubed divided by x cubed. All right, we're not done yet. We've got some more. Okay. Let's try a couple more, and then I just want to mention one more thing, and then I'll be done. how do we find the vertical asymptote?
Denominator.
Denominator equal to 0. So we could do shortcut. What multiplies to positive 6 and adds to negative 5? So what are my vertical asymptotes?
3 negative.
X equals positive 3 and positive 2. Okay. What's the degree of the top? The bottom? So what kind of asymptote is it? Oblique. So there's no horizontal. We have an oblique instead. So to find that, we set up the division. So we have an x cubed. You can put in like the zeros if you would like. It's not going to make a huge difference as long as you line things up. I think back when we did that, most of you did include those zeros, so it may be a good option here. All right, so then we divide. What is x cubed divided by x squared?
X.
So we'll put an x up here. Then x times all of this. So x times x squared is x cubed. X times negative 5x is negative 5x squared. X times 6 is 6x. Then what?
Put in the negative.
Run a negative through. Those cancel. 0x squared and 5x squared is 5x squared. And that's really all we need, because now I need to do 5x squared divided by x squared, which is 5. So my oblique is y equals x plus 5.
Why do you have to run the negative through?
Because when you do actual long division, like if I said 250 divided by 3. Okay, so you say how many times does 3 go into 25? That's 8, it's 24, and then you would subtract it off. That's why we distribute the negative. Okay. Again, right now, I'm not expecting you to have this technique down. We are going to continue working with it. Right now, I'm wanting you to recognize when we have those. This one, what's my vertical asymptote?
No.
0.
0. It's the bottom 0 is just 0.
0.
What's the degree of the top?
8.
8. The bottom. Okay. So to be a horizontal asymptote, the top has to be smaller or the same, and we don't have that. To be an oblique asymptote, what has to be true?
One.
The top has to be 1 higher, and we don't have that. So it's possible that you won't have either one of those things.
0.
All right. Way better than finding this. Last thing I just want to mention, just as a refresher, we will be talking about these more tomorrow. X and Y intercepts are the same for rational functions as they are for lines or anything else. How do you find an x-intercept? What is an x-intercept?
Where the line just
So where it hits the x-axis, and if you're on the x-axis, what's your y? So y-intercept is where the graph hits your y-axis. which means your x is 0. So if you want to find the intercepts, we know we just plug in zeros for the opposite variables. Okay, so this is my stopping point today. Tomorrow we will start combining all the stuff that we've been doing to draw graphs. Today your homework assignment